If you are over 60 and you have been eating the same breakfast for years, a bowl of cereal, a couple of slices of toast, some fruit and yogurt, a glass of orange juice, and your blood sugar numbers are still not where you or your doctor want them to be, I need you to consider something that most people in your situation have never been told directly. The breakfast you have been eating, the one you chose because it felt light, manageable, and reasonably healthy, may be the single most damaging blood sugar event of your entire day. Not because you are making an obviously bad choice, because the foods that dominate the standard American breakfast are almost universally the foods that produce the fastest, steepest glucose spikes of any meal. And those spikes, happening first thing in the morning when your cortisol is naturally elevated and your insulin sensitivity is already under additional stress, set off a chain reaction that affects your blood sugar for the next 4 to 6 hours. Today, I am going to show you exactly what the research-supported breakfast swap looks like, why it cuts post-meal blood sugar spikes by up to 40%, and why the specific metabolic changes that happen after 60 make this swap more important for you than it would be for someone 20 years younger. My name is Dr. Stephen Moss. If you are living with diabetes or prediabetes, this channel exists entirely for you. Every video I make is designed around one goal: giving you the information your doctor does not have time to sit down and explain. We are working toward 10,000 subscribers who are serious about taking their health back. And if that is you, hit subscribe right now and join us. Before I tell you what the swap is, I want to explain why breakfast specifically matters more than any other meal for people over 60 managing blood sugar. Because the case for changing breakfast is not just about what is in the food. It is about the unique metabolic environment that exists in your body during the morning hours and how that environment changes after 60 in ways that make a high-carbohydrate breakfast significantly more damaging than the same meal consumed later in the day. The first factor is cortisol. Your body produces a natural surge of cortisol in the early morning hours as part of its preparation for waking, a process I have discussed in the context of the dawn phenomenon in previous videos. Cortisol is a stress hormone that signals the liver to release glucose into the bloodstream in anticipation of the energy demands of the coming day. In a young, metabolically healthy person, this cortisol-driven glucose release is efficiently managed by the insulin response that follows. In someone over 60 with any degree of insulin resistance, that management is less efficient. The compensatory insulin response is slower and weaker. The cortisol-driven glucose is not cleared as quickly. And when you then eat a high-carbohydrate breakfast on top of a bloodstream that is already dealing with the cortisol-glucose surge, you are adding a second glucose event on top of the first before the first one has fully resolved. The result is a morning glucose peak that is higher and more prolonged than either event would produce independently. The second factor is something called the dawn phenomenon amplification that occurs specifically in people over 60 with insulin resistance. I covered this in detail in the bedtime drink video, but its relevance here is specific to how it interacts with breakfast timing. The dawn phenomenon glucose release peaks between approximately 6 a.m. and 8 a.m. in most people, exactly the window when most people are eating breakfast. Consuming a high-carbohydrate breakfast during the peak of the dawn phenomenon means you are eating the highest glycemic meal of your day at the exact moment when your body's background glucose is already at its highest point of the morning. The two events combine multiplicatively rather than additively. Research from Diabetes Care found that insulin sensitivity in the morning hours is measurably lower than at any other time of day in people with type 2 diabetes, and that this morning insulin resistance is compounded by the dawn phenomenon in a way that makes the same meal eaten at breakfast produce a significantly higher glucose response than the identical meal eaten at lunch. Your breakfast is fighting against your own biology in a way that no other meal does. The third factor is the loss of muscle mass after 60 that I have referenced in multiple previous videos, because it is directly relevant to breakfast in a specific way that is almost never connected to the morning meal. Skeletal muscle is the primary site of post-meal glucose disposal. When you eat a carbohydrate-containing meal, the majority of the glucose from that meal is absorbed by muscle tissue. After 60, without active resistance training to counteract the natural muscle loss that occurs with aging, many people have significantly less muscle mass available to absorb post-meal glucose than they did at 40. The same bowl of cereal that your body managed reasonably well at 40 produces a higher blood sugar response at 60. not only because of worsening insulin receptor sensitivity, but because there is simply less muscle tissue available to receive the glucose that insulin is trying to deliver. This is not a modifiable factor in the short term in the way that food choice is, but it is a critical piece of context for why the breakfast swap I am about to describe matters more, not less, as you get older. Now, the swap, and I want to be specific about both sides of it, what you are swapping away from and what you are swapping toward, because each side of this exchange has a precise biological explanation. What most people over 60 are eating for breakfast falls into one of three categories. The first is grain-based carbohydrates: toast, cereal, oatmeal, bagels, muffins, pancakes, or any combination of these. The second is fruit juice, which, as I covered in detail in the breakfast video earlier in this series, is essentially sugar water with good marketing, delivering the glucose of 2 to 3 pieces of fruit, with none of the fiber that would moderate its absorption. The third is low-fat flavored dairy, specifically flavored yogurts and low-fat milk, which, as I also covered, contain enough added sugar to produce a significant glucose contribution, while the low-fat designation removes the very fat that would have slowed the absorption of that sugar. What all three of these breakfast categories share is that they deliver a significant glucose load to your small intestine rapidly with insufficient protein, fat, or intact fiber to slow the rate of absorption. Your digestive enzymes convert them into glucose quickly. That glucose enters your bloodstream fast. Your pancreas, already working in a compromised morning environment against the cortisol and dawn phenomenon background, attempts to release enough insulin to manage the spike. The insulin response is slower and weaker than it should be. The glucose stays elevated for longer than it should. And the post-meal crash that eventually follows, when the delayed insulin response finally catches up and drives glucose down faster than it should, produces the mid-morning energy crash, the intensified hunger 2 hours after eating, and the craving for more carbohydrates that restarts the entire cycle before lunch. Now the swap. And I want to frame this as a complete breakfast architecture rather than a single food change, because the research demonstrating the 40% reduction in post-meal glucose spikes is not from changing one ingredient. It is from changing the entire composition and sequence of the morning meal simultaneously. The foundation of the swapped breakfast is protein, specifically a minimum of 25 to 30 grams of protein consumed at the start of the meal before any carbohydrate component. Research published in Diabetes Care found that increasing breakfast protein to this level produced significant reductions in post-meal glucose and insulin response compared to a lower protein breakfast with the same caloric content. A separate study from the American Journal of Clinical Nutrition found that high-protein breakfasts reduced appetite and caloric intake across the subsequent 8 hours more effectively than high-carbohydrate breakfasts matched for total calories, with the mechanism involving sustained elevation of the satiety hormones peptide YY and GLP-1. More protein at breakfast means a flatter glucose curve from the breakfast itself, a smaller insulin demand on a pancreas that is already working harder than it should in the morning environment, and a more sustained satiety signal that reduces the frequency of glucose events through the rest of the morning. The specific protein sources that produce the strongest combination of blood sugar benefit and practical breakfast applicability are whole eggs, plain full-fat Greek yogurt, and fatty fish. I have covered each of these in previous videos, but in the breakfast context specifically, 2 to 3 whole eggs cooked in butter or avocado oil represent the single most metabolically favorable breakfast protein available because they combine zero carbohydrate with high-quality protein and the fat that moderates gastric emptying from anything else eaten alongside them. Plain full-fat Greek yogurt delivers 17 grams of protein per 6-ounce serving alongside live bacterial cultures with documented insulin-sensitizing microbiome effects. Smoked salmon or sardines at breakfast, a standard practice in multiple cultures where metabolic disease rates are meaningfully lower than in the United States, deliver omega-3 fatty acids that reduce systemic inflammation alongside complete protein with no carbohydrate contribution. The second component of the swapped breakfast is fat, and this is the component that generates the most resistance from patients over 60 who spent decades being told that fat at breakfast, particularly at the morning meal, was something to minimize. The science on this has shifted substantially. Fat in the morning meal serves 3 specific purposes in the context of blood sugar management. It slows gastric emptying, reducing the rate at which any carbohydrate consumed at the same meal reaches the small intestine where glucose absorption happens. It triggers the release of cholecystokinin, a gut hormone that signals satiety to the brain, and reduces the appetite-driven carbohydrate seeking that high-carbohydrate, low-fat breakfast produced 2 hours later. And it does not raise blood glucose directly, meaning it is filling a portion of the morning plate with calories that make no contribution to the glucose load the pancreas must manage. Avocado, grass-fed butter, full-fat dairy from quality sources, nuts and nut butters without added sugar, and the natural fat in whole eggs and fatty fish all deliver this benefit without any of the inflammatory concerns that were historically associated with breakfast fat consumption. The third component is fiber, specifically the intact, structure-preserving fiber from non-starchy vegetables rather than the processed fiber from whole grain products whose grain structure has been milled away before baking. Adding a handful of spinach, some sliced bell pepper, mushrooms, or asparagus to a morning egg dish introduces soluble and insoluble fiber that further slows the digestion of anything else in the meal, feeds the gut bacteria whose composition determines insulin sensitivity over time, and fills the plate with nutrient-dense volume without adding meaningful carbohydrate. Research published in the Journal of Nutrition found that increasing vegetable consumption at the morning meal produced measurable improvements in post-meal glucose control across the following 4 to 6 hours, compared to the same caloric intake without the vegetable component. Now let me address the carbohydrate question directly, because I am not describing a no-carbohydrate breakfast, and I think it is important to be precise about that. The swap does not eliminate carbohydrate from breakfast entirely. It repositions carbohydrate within the breakfast from the dominant, first consumed, rapidly digested center of the meal to a small, fiber-rich, slowly absorbed component consumed after the protein and fat have already established the gastric environment that moderates its absorption. If you want fruit at breakfast, eat berries specifically. Blueberries, raspberries, and blackberries have among the lowest glycemic indices of any fruit available. They are rich in anthocyanins with direct anti-inflammatory effects on insulin receptor function, and their fiber content is intact in a way that moderates the fructose absorption from the same fruit. A small portion of berries eaten after eggs and avocado produces a completely different blood sugar response than a glass of orange juice consumed before anything else. The carbohydrate content is smaller, the fiber is present, the fat and protein from the eggs and avocado have already slowed gastric emptying, and the sequence means the berry sugar is arriving in an intestinal environment that is already moderating its absorption. If you want whole grains at breakfast, steel-cut oats cooked from scratch and eaten after a protein source represents the most metabolically favorable grain-based breakfast option available. I covered the specific reasons why steel-cut oats behave so differently from instant oats in a previous video. What I want to add here in the context of the over 60 morning metabolic environment specifically is that steel-cut oats eaten alongside or after a protein source, 2 boiled eggs on the side, a scoop of plain Greek yogurt stirred in after cooking, or a tablespoon of almond butter mixed through, produces a glucose response that is meaningfully lower than the same oats eaten alone. The protein and fat alter the gastric environment around the oats in a way that moderates the oats' own glycemic contribution. You are not abandoning oatmeal. You are surrounding it with the meal architecture that makes it safe rather than leaving it exposed as a standalone carbohydrate event. The 40% reduction in post-meal glucose spikes referenced in the title of this video comes from a combination of research findings that align consistently across multiple independent studies comparing high-protein, high-fat, low-glycemic breakfast compositions to the standard high-carbohydrate breakfast profile most people over 60 are currently eating. A study published in the International Journal of Obesity found that a high-protein breakfast reduced post-breakfast glucose area under the curve, which is the total glucose exposure over the 2 hours following the meal, by approximately 40% compared to a high-carbohydrate isocaloric breakfast. A separate study from Diabetes Care, specifically in adults over 60, found that replacing a grain-based breakfast with a protein and fat-centered meal reduced 2-hour post-breakfast glucose by a comparable magnitude, with the effect being most pronounced in individuals with the highest baseline insulin resistance. That 40% is not a marketing number. It is what the research consistently finds when comparing these two breakfast compositions in the population most relevant to this channel. And it represents a reduction that, applied every single morning, accumulates into meaningful A1C improvement over months of consistent implementation. Each morning, glucose spike contributes to your average blood glucose and through that to your A1C. Reducing the height and duration of that spike every single morning by 40% is not a marginal dietary adjustment, it is a primary intervention. Let me give you the practical version of this swap in the most concrete terms possible because I want you to be able to implement it at tomorrow's breakfast without having to figure anything out. Swap 1 is the most impactful and the most immediate. Replace whatever grain-based or fruit juice-based item is currently the center of your breakfast with 2 to 3 whole eggs cooked in butter or avocado oil, with whatever vegetables you can add to the pan alongside them. Spinach wilts in 2 minutes. Bell peppers take 3. Mushrooms take 4. This is a 5-minute breakfast that completely eliminates the glucose event your current breakfast is producing and replaces it with a meal that contributes 0 carbohydrate while providing 18 to 22 grams of protein and the fat that will slow the absorption of anything else you eat that morning. If you currently eat this alongside toast, eat the eggs first and eat less toast than you currently do, or switch to 1 slice of genuine sourdough toasted from frozen for the reduced glycemic impact I covered in the rice and potato video. Swap 2 is for anyone whose schedule makes eggs impractical on weekday mornings. Replace your current breakfast with 6 ounces of plain, full-fat Greek yogurt with a small handful of walnuts stirred in, a 1/4 teaspoon of Ceylon cinnamon, and a small portion of mixed berries added on top. This breakfast delivers 17 to 20 grams of protein, meaningful fat from the walnuts for gastric emptying modulation, the enzymatic inhibition benefit of the cinnamon, and the low glycemic carbohydrate from the berries in the most fiber-intact, lowest spike form available from fruit. Total preparation time is 90 seconds. Total metabolic benefit is substantially higher than the cereal, toast, or yogurt parfait it is replacing. Swap 3 is for anyone who genuinely cannot give up a grain at breakfast. Cook steel-cut oats the night before, refrigerate them overnight, and reheat them in the morning. This applies the cook and cool resistant starch protocol I described in the brown rice video to oats. Stir in 1 tablespoon of almond butter or a scoop of plain Greek yogurt after reheating rather than before to preserve the protein content. Add Ceylon cinnamon. Eat a boiled egg or 2 alongside it rather than treating the oats as the sole component of the meal. This is brown rice, thinking applied to breakfast. The grain is not the problem when it is surrounded by the meal architecture that modulates its effect. For all 3 swaps, 1 addition compounds the benefit of whichever option you choose. 1 tablespoon of raw apple cider vinegar diluted in a full glass of water, drunk through a straw 10 to 15 minutes before you sit down to eat. I have described this mechanism repeatedly across this channel, and I will not re-explain it at length here. What I will say is that in the specific context of the over 60 morning metabolic environment, with its cortisol background, its dawn phenomenon glucose, and its reduced insulin sensitivity relative to other times of day, the pre-breakfast vinegar habit produces a larger absolute reduction in the morning glucose spike than the same preparation consumed before lunch or dinner, because the baseline against which it is moderating is already elevated. The mechanism is the same. The benefit is larger because the morning environment was more compromised to begin with. Your breakfast is not just the first meal of the day. In the context of blood sugar management after 60, it is the meal that sets the metabolic tone for the next 4 to 6 hours. A high-carbohydrate breakfast consumed during peak cortisol and dawn phenomenon glucose against a background of reduced morning insulin sensitivity and diminished muscle mass for glucose buffering is the worst possible combination of factors to stack simultaneously. The swap I have described does not just improve breakfast. It improves the entire morning, the mid-morning hunger, the energy stability, the craving patterns, and the glucose environment in which your lunch will be digested. All of it starts with what you eat in the first 30 minutes after you wake up. 1 morning at a time. 1 breakfast at a time. Start tomorrow. I'm Dr. Stephen Moss. I'll see you in the next one.